one little example of a new application. I want to call up Craig again to show it. Here you are, Craig. Good to see you.
Long time no see.
Long time no see.
What we're actually showing here before we move on is this is the Asus E box, and this box here is actually pretty reminiscent of the world's fastest selling console. So when we're talking about doing some cool, innovative designs as far as running around, jumping up, and the entire interface change as far as how you're going to address PC gaming. All of this in a nice Atom-embedded system.
All right, so give us a bit more action here.
Absolutely. If we want to go ahead and start beating up some of our competitors here. This guy.
I spelled carpal tunnel syndrome.
And as you can see, for something like that, all gyroscopic in here, so extremely accurate, and even able to run your entire desktop. So I don't know if you've ever done email on something like this, but I'm up to 30 words per minute, Sean. You should check it out.
That's tremendous. An extension from the E family from Asus. Thanks a lot, Craig. That's a gyroscopic-based interface there. Again, lots and lots of innovation going on. Very, very good to see. Now, in the area of storage, we need also highly reliable storage that can be mobile for the next generation of these kinds of devices. So at Intel over the next few months, we're going to be working very hard with our partners on next generation solid-state disk drives. So these little guys look like disk drives, but actually they're full of flash memory chips, NAND memory chips that make them very high performance and for the kind of either for very rugged systems or systems that need more speed. 32 gigabytes up to 160 gigabytes. 1.8 to 2.5 form factors, much more rugged. Obviously, these kinds of things, you can drop them, they can consume relatively small amounts of electricity. Very interesting extension to the disk drive industry coming in over the next period of time. Okay, so we've taken a look at today's big announcement on the 4 series chipsets. We've taken a look at the Atom technology coming today, the Atom processor technology on the netbooks over here, and on the nettops, and on the newer embedded consumer electronics devices. Let's just take a last little peek at the next generation architecture that will be coming out a little way into the future. Again, using this 45 nanometer high-K technology, but pushing it ahead further with a new architecture, codenamed Halo. So let's see, what do we have over here?
Hey, Sean. So here what we have a brand new Atom running out of 2 SSDs, and we have a huge amount of data. Why is that? Because we have a lot of features. You know, when you go to a wedding, you take really features about 2 gigs, 3 gigs of data. And then, well, you start piling them, correct? And after a couple of years, how much data are we going to have?
So you're going to have, well, a wedding you'd have, how many pictures would you take at a wedding? Hundreds, right? So that's gigabytes on itself, just for the wedding. So how many gigabytes would you have for your life? You're going to have a lot of gigabytes. So the idea here with your desktop is for you to be able to manipulate your digital life. And what we have here is a kind of Minority Report style interface, which you may have seen. But the real trick here, which we're going to look at, is manipulating truly enormous amounts of data and diving into these JPEGs.
So here I'm basically picking into about 6,000 features. And what we're trying to do here, we are trying to see data, especially image, but not thinking it about as it is a data. It's something that globally, you don't remember where you put your data on the hard drive. What you want to remember is when you talk it and where you talk it. So this application allows you to do this, and you can see this very clearly. Here we were in San Francisco. If I zoom out, I can go to many other places. And if I go on the map,
So you don't care, as a user, you're just going to be taking tons and tons of JPEGs. They're going to end up in your hard drive. And in the Halem technology here, plus this amazing interface, means you can just dive and zoom wherever, and it will sort it by geographic location or by timeline.
Exactly. So this is a computer adapting to you and not the other way around.
Yeah, yeah, excellent. All right, thank you very much indeed. What you saw there is a sneak peek into the next generation microprocessor and logic technology, where the CPU performance is so high, the IL is so good, that you're going to be able to take your digital life, and you're going to be able to very simply scan through it, pull it out, look at it, share it, and so on. And that's on JPEGs. And you imagine what it's going to be like when you have to manipulate those high-def video images that all of us are going to be using. So we remain, in addition to these newer segments, lower cost, smaller power, Intel is hardcore committed to staying out there, pushing away, breaking the limits, faster, 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 because we know that microprocessor performance gets used up, and Halem will be coming along in the not too distant future. And I want to say a big thank you to everyone in the room, from the Taiwanese and international manufacturers who are working hard right now on the Halem development. Things are moving along very, very well indeed. Huge thank you from me. Okay, behind that, thank you. So the logic that we've talked about in the past is this concept of TikTok, which is we are on an accelerated rate of microprocessor development. Approximately every year to 18 months, give or take, we have another new wave of technology, either another new microarchitecture or a new wave of transistor technology. 45 nanometer high K, followed of course by 32 behind that, and successive generations afterwards. We believe, as do you, that the more we innovate, the more we pull consumers into our industry, the more we can work at solving that digital divide and bringing more and more people into this future of these new web applications that will enrich so many people's lives. It requires investment by all of us. In Intel's case, we are doubling down again to invest more and more and more around this generation of technology, somewhere in the range of $12 billion of capital, research and development, product development, technology development. And we remain more optimistic than ever, looking around the show here today, arriving here yesterday, more optimistic than ever on the future for the spirit and the hope that is represented by Computex, the spirit of developing new technology, driving the price of the technology down so that we increase the volumes. What you're seeing is the beginnings of the arrivals of the next generation, the big sister to Wi-Fi, WiMAX, for that mobile Web 2.0. This whole 45 nanometer high K generation, the high-end notebooks, the next generation desktops, and the smaller devices for your pocket or smaller, cheaper devices to bring more people into the industry. And truly for us, we believe that the future is brighter than ever. Have a great Computex. Thank you very much for coming along and enjoy the innovation. Thank you.